Greetings! Hello, ISDS2000 online students. Hope you're having a wonderful weekend. I wanted to touch base with you because we are just moving right along, rocketing through the semester and already beginning week 4 of the semester. So I want to touch base with you and just kind of see where we're at. Made myself some notes. You should be wrapping up Chapter 3, which of course begins with mean, median, and mode. I think hopefully those are familiar concepts to you, but there are some kind of interesting things that discussion allows us to bring out. One of the things is that it's measures of location, so we're looking at groups of data, or a bunch of data point or observations, and we're saying, where is the middle? And if I talk about something being on average, is the average truly the same as saying the middle of the data set? And of course we find that it's not. As you look at the average, you may find that it is to the left of the median or to the right of the median. And of course this brings up the concept of skew. But before I move on to that, the big thing that I want you to look at the beginning of Chapter 3 is the formula for calculating the average. I say formula, but I should say formulas, because there's two I want to talk about, and then of course there's actually a third as you get towards the end of the chapter. As you look at the formula, you see these weird symbols like a capital Greek S, the sum symbol, right? And it says sum x. Well, I want you to kind of get that in your mind now, that what that means is that you're taking each and every value of x and summing it. Because as we start to calculate standard deviation, the order of operations will be very, very important. Now, let me talk about order of operations. Some of you have heard the phrase, the acronym or mnemonic phrase, please excuse my dear Aunt Sally. And that means that parentheses always are processed first. Excuse E for exponents are next, right? Please excuse my, M for multiply, dear, D for division, right? And on and on. Now, on the one hand, we know that, and we tend to put that knowledge over here, and then when we start to put stuff into our calculator, we kind of forget about those concepts. So, I wonder if you can see this on the video. It says, what is the answer? And for example, if you type this into your calculator, or into Excel for that matter, 1 plus 3 divided by 2. Now I want you to honestly tell me what you think the answer is. If you said 4, you're wrong. And that means that you didn't follow the order of operations. Because remember we just said P, parentheses, comes first, and there are none. There are no exponents, okay? So there's none of that. But the next thing we said is either multiply or divide, and I see division here. So what we need to do is say 3 divided by 2. Well, 3 divided by 2 is 1.5. 1.5, then the next operation is 1, would mean that the answer is 2.5. So just like your brain, even as I explain this, some of you are probably going, oh yeah, that's right. But as you're doing your mathematical calculations for statistics, this is the easy kind of mistake that you can make if you're not paying attention. And it's oftentimes why I encourage you to write down your work, and even to do it in Excel. As an online student, if you email me your work in the Excel spreadsheet, it's easy for me to point at this and say, did you realize you forgot your parentheses, for example? When you do it on your calculator, what tends to happen is you say to me, look, I typed it in there correctly, because of course you're not going to type it in there incorrectly in your mind, right? You're doing what you think is right. So it becomes impossible for you to send that to me and for us to look at it together. So Excel is very good, but even Excel is going to follow the order of operations. And so just kind of double check yourself on those kinds of work. Okay, order of operations is going to be really, really important as we go forward. Another thing that I want you to observe in those in the formulas are the differences in symbols. When you see a lot of Greek letters, we are talking about calculations for a population. typically regular English letters tend to be calculations for a sample. And as you work in the business world, it's important to follow those rules of communicating with your colleagues. So, for example, if you say, I'm just going to make up a number here, and I hope you can see this, that the average is, I don't know, 5. We do some calculations, and I do that. Can you see that? My table messed up here a little bit. That's supposed to be mu. If I say mu equals 5, that's a Greek letter. And so what I have indicated to the person reading this is that that is the population average. I've gone out and talked to everybody, been calculating, I don't know how many times they work out a week, because you work out 5 times a week, right? Now, if on the other hand, I had asked my really bulky workout cousins, 2 of them, and that's my sample, and they tell me we work out every single day, but it was just a sample of all the members of my family, that would be X bar. So what I'm communicating with X bar is that it is the average of a sample. Mu means average of a population, and that's important, okay? 2 other symbols that you'll see in Chapter 3 are sigma and S, both indicating standard deviation. So if I say that sigma equals 2, see that there? This is a lowercase Greek s, S for standard deviation, but it's sigma, lowercase, and that would mean that the whole population of my family, let's say, works out 5 times a week, plus or minus 2, because the standard deviation in this case for the population is 2. Now, if I did that same example for a sample, instead of using Greek letters, I would just use the letter S, because S means for the sample, okay? So Greek letters mean population, whereas X bar is not really a regular letter, but kind of the regular English alphabet typically means a sample. These are important things to get in your psyche now, put them in your mind now, so that as we continue through the chapters, you're very comfortable with them. Now, speaking of population means and medians and modes, the next thing that you'll calculate is skew. And skew tells us what the shape looks like. Now, the first thing that I want to point out is that there's one very special shape, and that is the symmetrical shape. And the symmetrical shape you probably have been a victim of. It's a bell-shaped curve. You'll also hear it called a normal curve. Now, you can make kind of a curve or a smooth curve out of a histogram, which we've been looking at and studying. Mean. But if mean equals median equals mode, we know that the shape is symmetrical, okay? So those 3 values immediately, if they equal each other, it is symmetrical. If those values don't equal each other, then we know that the data is skewed. Now, the next question you might say is, when we say skew, is there a big bump over here, or is there a bump over here? Well, it depends what direction it's skewed. And we know that the median is always in the middle, right? So if the mean moves in the negative direction, if it moves to the left, we would say that the data is negatively skewed. Now, don't pay attention to the bump in the data. That's a common mistake. But if the mean moves to the left on a graph, anytime we move to the left on a graph, we're moving in the negative direction. Same thing for if the mean moves to the right. The right on a graph is the positive direction. So again, we typically are looking at the tail. This is called the tail of the data, not the bump in terms of that. But of course, statistics, we want a specific value for that bump, and so you'll have some calculations there to calculate the skew. I do have you do that. I know that they're lengthy calculations. The reason I have you do that is because I really want you to get comfortable with repetitive calculations, but most importantly with the order of operations. I think everybody knows how to multiply, subtract, add, divide, all those kind of basic math functions, and that's all you're really doing here. You know, there's some exponents involved. It's not difficult math, but it is procedurally important to follow each step precisely. You know, formulas are often described as recipes, and if you don't follow the recipe step by step, you run into trouble. And the key to that is being very, very organized. Okay, so make sure you are approaching it in a very organized way. One thing that will help you with that is some of the extra credit assignments that I have in Excel. So don't forget to make time for those extra credits. A couple things I'll do is just touch base with you on the status. So far, remember you have Learning Project 1 due on February 9th, and so far 7 people have turned that in, and congratulations to those 7 people. You're doing exactly what you need to do. So you've played with Excel a little bit, and you're seeing how graphs work. 4 people have already done the Chapter 2 extra credit. That's fantastic, because it's going to help you with the homework. 1 person has turned in Chapter 3 extra credit, and I have 1 person who's working out there on Chapter 4. Kudos to you. And 1 person has already turned in the Chapter 4 extra credit. Now, speaking of that, this is just a little graph, I don't know if you can see that, of how our class is doing, but let me tell you the most important thing. We have so far 17 people that have gone out there to the Connect website. You've registered your code, and that is great. You should be doing that. Great job. You're out there doing it. Now, Chapter 1, I've already got 14 of the 17 who have finished that, and I am happy to say practically everybody has a perfect score on that on Chapter 1 in Connect. Excellent. Great job. For Chapter 2, I have 9 of you who have finished that, and you've met your minimum score requirement, because remember we said for the homework the minimum score requirement was 85%, and so you've done that. Beautiful. Great job. I got 1 person who's still working on it, but I'm not worried about you because you're out there working, and that's the most important thing. For Chapter 3, remember that there are 2 parts. You should be finishing up the reading and the kind of extra credit for that this week, but I know that weekends are your weekend warrior work modes, and so I know that these numbers will go up, but so far I've got 2 people who have done Part 1 and 1 person who is about finished with Chapter 3 Part 2. I even have 1 person who's gone on to knock out Chapter 4 Part 1 and Chapter 4 Part 2. So, keep working. If you have questions, be sure to email me and ask me. The most important thing, make sure you have a very organized approach, that you send me the entire word problem as well as the numbers that are included in the word problem, and describe what formula you want to use and any calculations that you've already taken. In that way, I don't make you, go back and cover things that you already understand. The more you tell me, the more details you provide, the better able I am to point you in the right direction. I did tell you that I was going to talk about 1 more formula to calculate the mean for grouped data. And what that means is that they are going to give you the frequency table. Well, remember, by definition, the frequency table means that you've already summarized and grouped up your raw data. And in some cases, in business, you're not going to have the raw data anymore, or else the raw data is too overwhelming for you to take apart. So instead, what you're going to do is look only at the frequency table and calculate an average. What typically upsets students at that particular point is that you feel that that average is not accurate because you're basing it off of summarized data rather than the true individual data points. That's okay. The whole goal there is that you are somewhat doing an estimate. Last thing I want to talk about is I tell you to keep up the good work. I have another video called Empirical Rule in 5 Minutes, and I would encourage you to look at that because you do have some empirical rule questions, and we're going to use that throughout the semester. It actually makes your life a little bit easier if you understand how to use that and the information that the empirical rule provides. So keep up the good work. You're doing a great job, and we'll talk to you again soon.